So hello everyone, in this video we are going to look at a new topic, like we are starting a new topic and a new sub-series which is called as bit manipulation. Bit manipulation. It is not like extensively used, but it comes very handy in some typical problems and then solving via bitwise operators or concepts of bit manipulation actually reduces time complexity and makes it quite easy to solve the problems by reducing the time complexity as well. So this particular video is not much about coding and related stuff. This is going to be an introductory theoretical video, but as far as I know, this particular video is going to help you a lot in clearing many basics, and these basics are something which are very essential to learn. So first thing about which is compulsorily required is you must know how to convert how to convert from decimal to binary and vice versa so actually you should know how to convert from decimal to binary and vice versa. I am not going to discuss about these basics, that how we convert from a decimal to binary. I think this thing you should know. Okay, so let's talk about some bitwise operators. Bitwise operators. Bitwise operators. So first bitwise operator is AND, logical AND. Then second bitwise operator is OR, logical OR. Another bitwise operator is actually what we call this left shift, and another is called as right shift. Right shift. Perfect. And there is also one more which is XOR. XOR. Okay. So we can discuss about these in details one by one. So, but before moving forward, we should look at some rules. So, rule number one is that let's consider a number 5. So, how is 5 represented in binary? So, it is 0101 like this. How it is? How is 4 represented? It's okay. Did I make a mistake? Like 0 4 0. Okay. 0 1 2 2 square 4. Okay, correct. Then 0 1 0 0. This is 4. Then what about 7? So 7 is actually 0 triple 1. What about 8? 8 is actually 1 triple 0. And what about 9? So 9 is actually 1001. And what about 10? 10 is actually let's say how can 1010. Okay, perfect. So based on these observations, okay, so based on these observations, what can we draw a conclusion? So our conclusion is, if a number is odd, okay, if a number is odd, then every odd numbers end with bit 1. So see, 5 end with 1, 7 end with 1, 9 end with 1. And if the number is even, then it end with 0. So odd numbers end with bit 1. Even numbers end with bit 0. Perfect. Odd numbers end with bit 1, even numbers end with bit 0. Then let's move to our second rule. And what's the second rule? Rule 2. It states, suppose I do 1 and with 1. So answer is 1, and 1 and with 0. So answer is 0. So if I do 1 and with x, so answer is basically x, where x is 0 or 1, anything. X could be anything, 0 or 1. So 1 and with any bit, whether it is 0 or 1, answer is the bit itself. What's the rule 3? Rule 3 is also quite simple. Let's suppose I need to do 0 and x and 0 or x. So answer is 0 for 0 and x, and answer for 0 or x is x, where x could be either any bit, either 0 or 1, any bit. So while doing AND with 1, make sure that whatever bit you are doing, answer is the same bit itself. However, if you are doing 0 and x, the answer would be 0, and 0 or x, the answer would be x. Perfect. Then rule number 4, which is also quite easy. Rule number 4. Rule number 4, which is also quite easy. And what does the rule states? Rule states that XOR is also known as, I hope you are making notes side by side, because my handwriting may not be so good digitally, but in copy you can write these rules in a very systematic way, and these notes will help you in future. So XOR is also known as odds 1 detector. Odds 1 detector. So what is this exactly? So what is the table of XOR? Suppose A XOR B I have to do, and this is my output. So what are the possible combinations? So possible combinations are 0 0, 0 1, 1 0, and 1 1. So 0 0 XOR is 0, 0 1 is 1, 1 0 is 1, and 1 1 is again 0. Perfect. So through this example, you may come to know that whenever there are odd number of 1, so in 0 and 1, 1 is occurring one time. So whenever bit 1 occurs odd number of times, output is 1, that is high. Similarly, for 1 0 also output is 1, but for 1 1 output is 0. So if there is suppose a long chain 0 XOR 1 XOR 1 XOR 0 XOR 0 XOR 1 XOR 1 XOR 1 XOR 0 XOR 0 XOR 1 XOR 1, and you are asked the answer. So simply what we will do is we will count the number of ones. So 1, 2, 3, 4, 5, 6, 7. So there are odd number of ones. So answer is going to be 1. Okay. So XOR is also known as odds 1 detector. Okay. So this was rule 4. Now let's move on to rule 5. Rule 5. Any number, any number XOR with itself. Any number XOR with itself is oh, not is gives output 0. ठीक है. So 5 XOR 5 is always 0. Okay, so we can also verify this actually. So 5 is actually 0 1 0 1, and another 5 is 0 1 0 1, and we need to do XOR of these two. So 1 XOR 1 is 0, 0 XOR 0 is 0, 1 XOR 1 is again 0, and 0 XOR 0 is 0. So output is 0. Perfect. So also, so the rule is quite simple. Any number XOR with itself gives output 0. You can even try this on your own with some another example. Now these last two rules are all very important. So rule number 6. Rule number 6 is any number x left shift 1 is basically x multiplied by 2. So actually 5 left shift 1 gives answer 10. 5 left shift 1 gives answer 10. How? Let's verify it. Let's verify it. So 5 is what? 0 1 0 1. And what is 10? 10 is what? 8 plus 2. So 1 0 1 0. So if you left shift this, 5 is equal to this and 10 is basically equal to this. So if you left shift this 0 1 0 1 by one position, left shift by one position, you get, so this one would come here, this 0 would come here, this one would come here, and here it will become 0. So 1 0 1 0, and these two are actually same. So x left shift 1 is basically x into 2. But then now question arises is that what is x left shift 2? X left shift 2. So let's try 5 left shift 2. So 5 is what? 0 1 0 1. Okay, one left shift would do 1 0 1 0. Another left shift would do 1 0 1 0 0. Yeah, something like this. So it would become what? 0. Okay, 1 2 4 8 16. 16 plus 4 is 20. Okay, perfect. So basically 5 left shift 2 was 5 into 2 into 2. That is 5 into 4 and equal to 20. So basically, so our rule says, rule 6 explicitly says that x left shift k is equal to x into 2 to the power of k. x into 2 to the power of k. This is a very important property and I want all of you to remember this. This is a very important property. So basically if someone asks you 5 left shift 2, so it would become 5 into 2 to the power of 2. So 5 into 4 is equal to 20. Similarly, if someone asks you 6 left shift 3, so it becomes 6 into 2 to the power of 3. So 6 into 8, that is 48. Perfect. Now, rule 7. Rule, rule number 7. Rule number 7 is also quite easy. Rule 7. Rule 7 is quite easy. So, how would you define x right shift to 1? So, x right shift 1 is actually given as x divided by 2. So basically if I say 8 right shift 1, then it is basically 4. Now how? Let's verify it. What is 8? So 0, 1. Okay, so 8 is actually 1000. And if you do right shift by 1, it would become 0, 100. And this is nothing but 4. Similarly, let's consider you have a number 12 and you have to right shift 12 by 1. So answer should be 6. So let's verify it. What is 12? 12 is actually 1100. And if you right shift this, so it would become 0110. So this is what is 12 and 0110 is nothing but 6. So anything right shift by 1 is divided by 2. But then the question arises, what if I do, let's say 12 right shift 2? So 12 is what? 1100. Okay, first we will do right shift by 1, so it becomes 0110. And then again we will do right shift by 1, so it becomes 0011. So this was 12. Right shift by 1 becomes 6, and then it becomes what? 3. So final answer is 3. So to generalize this, rule 7 says x right shift by k is equal to x divided by 2 to the power of k. This is the formula, and this is the most important property I wish you to remember. So basically these were the 7 rules which I wanted to discuss with you as far as this video is concerned. So first we have discussed some bitwise operators like AND, OR, XOR, left shift, right shift. Then what was rule number 1? Rule number 1 was that every odd numbers end with 1, bit 1, and every even number ends with bit 0. Then 1 and 1 is equal to 1 and 1 and 0 is equal to 0. So basically 1 and x is any bit x is equal to x. 0 and x is equal to 0 and 0 or x is equal to x. Then XOR is also known as odds 1 detector. We have seen a long chain of example. So if it comes to that you are given a long chain of bits and you have to find XOR of all those bits, then you just simply count the number of times bit 1 is occurring, and if it is odd, then answer is 1, and if it is even, then answer is 0. Similarly, rule 5 states that if any number XOR with itself gives output 0, like 5 XOR 5 would be 0. You can also verify with this with other examples. Then rule 6 basically states that x left shift k times is x into 2 to the power of k, and x right shift rule 7 states x right shift k is basically x divided by 2 to the power of k. So that's it in this video. Now, as far as code is concerned, I have coded this. So I want you to find output of this on your own. Use pen and paper, please. And it's quite simple. So 5 XOR 6 you can find on paper, 5 or 6 you can find on paper, 5 and 6 you can find on paper. Similarly, 5 left shift 2 would be what? 5 into 2 to the power of 2, that is 20. Then 6 right shift 1 would be 3. So if I just execute this, if I just execute this, you can see that these are the outputs we are getting and they are all correct. So this was just an introductory video. This was just an introductory video for what we say, for bitwise operator and bit manipulation. So these are just basics. We will solve problems and understand some other concepts in my upcoming videos. But as far as this video is concerned, I wanted to give you a brief about some basic rules, some basic bitwise operators, how they work, and I hope you have understood these concepts very well. Please try to code this particular part like this on your own and check if you are getting correct output in your own IDE. This will help you to gain some more clarity. So that's all for this video. Thank you for watching till end, and if you think I have made any significant contribution to your logic building, please do consider subscribing, and I will see you in the next one. Thank you.